I hope I am audible and my screen is visible to everybody.
Yes, sir.
ठीक है. So today we are going to start another topic. This is a new topic, and we'll be starting with the numerical integration part. Now, let us first of all understand what do we mean by this numerical integration with the help of some of the graphs. Okay, so let us say we have uh, x-axis and y-axis over here. So this is your x and this is your y, and let us say we have a curve which is like this. Okay, and this curve is denoted as y as a function of x. Okay, now this means what? As the value of x is increasing, the value of y is also increasing. Okay, so you can see the graph is having an increasing trend. Okay, now let us understand what is the integration means. So let us say I have 2 points. Okay, so let us say this is my point number say a, and let us say this is my point number b. Okay, so when I say that I is the integration from a to b. Okay, so these are the limits of f of x dx. Okay, what do we mean by this? The meaning of this is the area under this particular curve within the limits. Okay, so this area, the shaded portion, is nothing but your integration part. Okay, now as far as civil engineering is concerned, this is very much important because this red line can be even a stress, and if you integrate the stress you are going to get the value of forces. Okay, so this is very much important as far as the engineering is concerned. Now if you do not have the correct answer to the integration, definitely your the force or the integration value, it will not be accurate, and further it will lead to different type of some errors. Okay, so in order to calculate the correct area under the curve, okay, so we have different methods. The very first and very basic method is the trapezoidal method, which we are going to study today. Then we have some improved methods like Simpson's method, and then we have some very accurate method, that is the Newton-Gauss quadrature method. Okay, so this is the significance of this particular topic. Now to understand this, let us quickly try to develop the equation for the trapezoidal method. So for example, I have, this is your x-axis. Okay, so this is your x-axis, this is your y-axis, and again we have a curve which is going like this. Okay, then we have a lower limit, so this is your point number a, and we have, this is your upper limit, this is your point number b. Okay, so this is your point number b. So now as far as the coordinates are concerned, we have this as your x1, this is nothing but your y1, and this vertical component will be y1. Okay, so this is x2, or rather I should write xa and xb, that will be better. So let us call this as xa, this will be xb, the vertical side will be ya, and this vertical side will be yb. Okay, now one of the crude method of finding out the area under this curve is, what we can do is we can assume a straight line relationship between point a and point b. Okay, so like this. So now it will be easier for us to find out the area under this trapezium. Okay, so this is nothing but a simple trapezoidal shape. Okay, so this distance is nothing but xa, this distance is xb, this vertical will be ya, this vertical will be yb. Okay, so if you want to calculate the area of this trapezoidal shape, you can have a simple expression, something like we have the width. Okay, so this width, usually we call this as h. Okay, so h can be calculated as xb minus xa. So this is the height, sorry, this is the width, and as far as height is concerned, so we have to take the average height. So average height can be calculated by a simple expression, that is ya plus yb, sorry, yb divided by 2. Okay, so all we have to do is just multiply h with the average height. so that your integration now will become something like h into this is ya plus yb divided by 2, isn't it? So you can rewrite this expression in form of this is something like h by 2 into ya plus yb. Okay, so this is a very basic equation which can be used for calculation of integration using the trapezoidal method. Okay, I hope this is clear to everybody.
Yes.
Okay, now the drawback of this particular method is, so when you are using this type of method, the portion which is shown in this orange color, okay, so this is ignored, isn't it? So this part is not at all considered. Okay, so now because of this actual area under the curve and what area you have calculated, they are slightly different, or rather I should say there are some errors as far as the area is concerned, which is calculated using the trapezoidal method. So this is not going to give us the correct value. So what we can do is, in place of going for simple integration, we can do the same thing in different way. Okay, how? Let me show you. So I'm going to draw the same figure one more time. Okay, so let us say we have this as x, again we have this as y, and we have a curve which is like this. Okay, and then I have this is point number a. Okay, this is, let us say, your point number b. So it is like this. Okay, so this will become xa, this will become xb, and this will become ya, and this will become yb. Okay, so now what we are going to do over here is, we are going to take one intercept which is exactly between xa and xb. It is exactly at the center. Okay, so I'm going to take one more point over here. Let us call this as x1. So the corresponding value will become y1. Okay, so now uh, if you want to calculate the integration, okay, so in this case what we are going to do is, we are going to assume a straight line relationship between from this point to this point. Okay, and another straight line relationship between this point to this point. Okay, so now if you assume this kind of scenario, in that case what will happen, the portion which is ignored, okay, the portion which was not considered in the integration, that is this shown in blue color, so you'll find that this portion is having a lesser area. Okay, so as compared to the previous case, the error which is coming over here, it is slightly less, so error is basically reduced. Okay, so now if you want to do the integration part, so you have to calculate the trapezoidal area of this trapezoidal and trapezoidal area of this trapezoidal portion. Okay, so the integration will be area of this first plus area of this second portion. Okay, so if you want to calculate the area of the first portion, so this will be something like h. So now here h will be like this. Okay, so in earlier case the h is the full, that is the distance between xa and xb, but now here h will be xa and xb divided by 2, that is exactly half of that. Okay, so I'm going to write down here h by 2 into, so you have now ya and y1, isn't it? So this will be ya plus y1. So this will be the area of the first trapezoidal. Then if you want to calculate the area of the second trapezoidal, so this will be y1 plus what? yb. Is it okay? So now if you expand this, what you are going to get is something like this. This is h by 2. I'm going to take this as outside. Okay, so this will be common. So if I add these two, okay, so if I add these two, what I should get, something like ya plus 2 times y1 plus yb. Okay, so this is how the equation is developed. So this is again the equation of trapezoidal method when we are only taking the two iterations or the two sections. So xa and xb, they are divided in two equal parts. Okay, but still in here also you will find that there is some error, and because of this we are not able to get the actual answer. Okay, so now what we can do, we can even go for more number of intervals between xa and xb. So for this purpose what we will do, we will draw one more graph over here. So let us say this is your x and this is your y. So I'm going to consider the same equation, same curve. So your curve is something like this, and still you have 2 points. Okay, so this is point number A, okay, over here. So that this will be your y1, this will be your x1, and here this will be your point number B. So you have this as xb and this as yb. Okay, so now earlier in the previous case we have taken only the mid of that. So in place of that, now what I'm going to do, I'm going to consider two different points like this. They are at the same interval. So one point is over here and one point is over here. So that this is, sorry, this is xa. So this will become x1, this will become x2, this will become y1, and this will become y2. Okay, so now as a result of this, what you are going to do is you are going to assume a straight line relationship like this, then again like this, and then again like this. So now you see the amount of error. So here you see this area is not considered, so this area is very very small. So you see, if you are increasing the number of intervals between xa and xb, your amount of error is going to get reduced. Okay, so now you have now three parts. The first part is this one. So this is the first trapezoidal. Okay, this is the second trapezoidal, and this is the third trapezoidal. Okay, so finally the integration can be calculated as area of first plus area of second plus area of third, isn't it? So if you calculate this area, so now this entire width, that is xa to xb, now it is divided into three equal parts. So the h value is now total length between a and b divided by now 3. So the equation can be written as h by 2 into, now you will have this is I think xa. Okay, not y, sorry, this is not y, y1, this is ya. So this will be ya plus y1. Okay, then the second area is h by 2 into, this will be y1 plus y2, and lastly this will be h by 2 into y2 plus yb. Okay, so if you rewrite all these expressions, so you have one y1, another y1 over here, this is common, this is y2 and this is y2, which is also common. So h by 2 into, you can have ya plus 2 times y1 plus 2 times y2 plus yb. Okay, so this is another equation of this trapezoidal method for the numerical integration. Okay, but if you compare these three equations which we have generated recently, so you will find in this particular expression there is no uh, y1. Okay, because we have just taken direct integration. Here you have only one y1 term. As far as here it is considered, in the third equation you will have y1 and y2. So if you increase the more number of intervals, what will happen, you will have another y, that is y1, y2, y3, or maybe even y4. So in short, you can rewrite this entire expression, that is I equals to h by 2 into ya plus summation of 2 times yi. Okay, so where this I value will be starting from 1 up to n. So n is basically whatever number of intervals you want, that you have to write, plus then you have now yb. Okay, so this particular expression will be now the final expression for the trapezoidal method. Okay, I hope this is clear to everybody. Are there any queries? Yes students, are there any queries?
No, sir.
ठीक है,
No, sir.
ये आया समझ में? ठीक है.
Yes, sir.
Okay, so it's a simple derivation of the this trapezoidal method. Okay, do you want some time to write down this? Sorry. Done. Okay, so let us jump to the numerical part then. Okay, so this is the derivation part. So let us take one example over here. Okay, so now this example is very simple. So here I want to calculate what will be the value of the integration, that is integration of uh, so I want to know what is the integration. I is equal to integration from 0 to 1, so the lower limit is 0, upper limit is 1, of 1 upon 1 plus x into dx. Okay, so I want to know its value, its actual solution. Okay, its actual solution is something like log to the base e of 2. So its corresponding value is 0.693147. So this is the actual solution. So we'll try to find out what exactly is happening. Okay, so let me start with the solution then. Okay, so now let me explain this with the help of figures. So we have a equation which is like this. Okay, and we want to find out what is the integration from 0 up to 1. Okay, so 2 points are given, one is 0 and one is 1. Okay, so now in this expression, if you substitute x as 0, okay, x as 0, so corresponding y is nothing but what, function of x. And what is your function of x? This is 1 upon 1 plus x. So when x is 0, okay, so y will become 1 upon 1 plus 0, so this is nothing but 1. So when x is 0, so this value will be 1. Okay, now when x is equal to 2, oh sorry, x is equal to 1. Okay, so y value will be 1 upon 1 plus 1, so this will become zero point 0.5. So here we have this value as zero point 0.5. Okay, now if you try to plot a curve, I don't know, it can be like this or it can be going like this. I don't know which one is the correct pattern. Okay, so let us assume that the pattern is like this, and basically I want to find out what is the area under this particular curve. Okay, so this area is nothing but your I. Okay, so now if we are not using any interval, so let us say we are using a straight line like this, so what is going to happen? This portion will not be considered in the integration part. As a result of this, I will be nothing but h by 2 into, this is हमने क्या लिखा था यहाँ पर, ya. Okay, so let me write down the same, this one, this will be ya plus yb. Okay, and what will be your h? This is nothing but your h. So here, if you don't have any interval in between, so here h will be 1, because this is h is nothing but xb minus xa divided by nothing. We are not going for anything. So this is 1 minus 0. So this will be 1 only. Okay. So this is 1 divided by 2. Now your ya is nothing but this value, that is 1. Okay. Plus yb is nothing but this value, that is 0.5. So this is 0.5. So this comes out to be 1.5 divided by 2, that comes out to be 0.75. Okay, now if you refer the actual solution, we are quite far away from the actual solution. So that's why you'll find this much of quantity. Okay, the portion which is shaded over here, this is nothing but error. Okay, so to avoid this error, what we have to do, we have to go for more number of intervals in between a and b. Okay, so let us try to do this, and let us keep only one interval and see what is going to happen. Okay, so we have one more curve like this, and this time you will be drawing a curve on the similar pattern, and we have this. Okay, so here we have 1 and here we have zero point 0.5. So this is nothing but 0 and this is nothing but 1, but this time I will be going with the one more interval over here. Let us say this will be now zero point 0.5. That is exactly the center of the upper limit and lower limit. So this will be zero point 0.5. This will be also zero point 0.5. So this is the center point. So I need to calculate what will be this value. Okay. So for this, our function of x is nothing but 1 upon 1 plus x. So this is 1 upon 1 plus. So x is now zero point 0.5. That is 1 upon 1.5. How much is that? Anyone? 1 upon 1.5. How much is that? 0 point, let us say 66667. So this is 0.66667. Okay. So now since we have one interval, so I can be written as h by 2 into this will be ya plus 2 times y1, okay, plus y b. So your h value this time it is zero point 0.5 divided by 2. Ya is nothing but this value which is 1 plus 2 times y1. So this is nothing but your y1, that is into 0.6667 plus yb is nothing but zero point 0.5. Okay. So now can anybody tell me what will be the value of I?
0.70.
Sorry, 0.70833. Okay. So now if you observe carefully, this value that is 0.708 and this was 0.975 and actual answer is 0.69. So you see the amount of error in this particular case, this is more, and in this particular case, the amount of error it is slightly reduced. Okay. So now you see when you are using one interval, so you are getting a value which is close to the actual solution. So actual solution is 0.69 and what you are getting is 0.70. Okay. So you can see we are quite closer to the solution and you just see the effect that we have just taken only one interval. Okay. So let us go for further and let us go for two intervals in between and see what is going to happen. Okay. So I'm drawing a slightly bigger figure now. Uh, so it is like this and we have a vertical line like
Sir,
this. Yes.
sir, by observing the previous tables, we can predict that the curve is concavity upwards as the value is reduced.
So is it like this?
Yes, sir.
Okay. No issue. So we can draw curve like this. Okay. No issue. Okay. Let me reduce this one also. Here is this one also. I'll use the red color. Okay. So it is like this. Fine, not a problem, right? So here now this time I'll be using intermediate 2 points, okay, which is exactly at the or rather it is dividing the 1 0 and 1 in equal parts. Okay. So now this will be 0.3333 and this will be 0.66667. Okay. So the corresponding y values here, this will be 1, okay, and this will be 0.5. So I'll be using a simple table now. So your x1 and your x2, so your x1 is 0.3333 in between and this is 0.6666. So your y1 is nothing but 1 upon 1 plus 0.3333. Give me the values please.
0.750.
Okay, and how about this one? 0.6. Is it so? बराबर है ये? Somebody please confirm.
0.599.
Sorry?
0.5.
हाँ वो 0.6 ही है वो. ठीक है? That is probably round off error. Okay. So now here we have this value that is 0.75. Okay, and this is 0.6. Okay. So now you can have the integration that is I equals to h by 2 into ya plus 2 times y1 plus now here you have 2 times y2 because y2 is coming into picture, and plus yb. So your I value is h. So h is basically the interval now between the consecutive values of x. So now this will be 0.3333, this will be also 0.3333, and this will be also 0.3333. Okay, so 0.3333 divided by 2 into ya is nothing but 1, and this is 2 times y1 is 0.75, plus 2 times y2 is zero point 0.6, plus yb we have already calculated as zero point 0.5. Okay, so now can somebody tell me what will be the value of I then?
0.6999.
Sorry,
0.6999.
triple nine. Okay, so now you see
Yes.
we are reaching closer to the solution, because earlier it was 0.708, now this is 0.699, and actual solution is 0.6931. Okay, so you see, you increase the number of intervals between a and b, so your error is going to get reduced. Okay, I hope you have understood this, everybody.
Yes, sir.
ठीक है. So now I want all of you to solve this problem, okay, with greater number of intervals. Okay, so can you do this with, let us say, 8 number of intervals? Okay, can you do this, please?
Yes.
Please do that.
Yes.
Are there any queries? Yes, anybody got the answer?
0.6941
6 9.
41.
Yes, correct है.
0.6940.
412 आना चाहिए एक्चुअली. वो डिपेंड करता है तुमने कितने वैल्यूज लिए. आर यू गेटिंग दीज वैल्यूज करेक्टली? प्लीज चेक.
Yes, sir.
ठीक है
Yes,
फिर.
sir.
ठीक है, ठीक है. वो एक्चुअली 0 पॉइंट जैसे ये वाला वैल्यू है ना, दैट इज 0.8888, सो देयर इज अ पॉसिबिलिटी ऑफ राउंडिंग ऑफ एरर्स, बट एक्चुअली इफ यू यूज अ कंप्यूटर प्रोग्राम you should get the answer as 0.69412. Okay.
Sir, I took 4 places after this. Yes.
Okay, fine, good. Everybody done, or you want some time?
Let's
Okay. So you see the actual answer is like uh, 0.6931. Okay. So 0.6931, and what we are getting is 0.6941. Okay. So even after taking 10 intervals, you will find there is some amount of error which is still there in the actual solution. So if you want to have the actual solution, then what we'll have to do, you have to go for even more number of intervals. Okay. So now I hope you have understood this. I don't think there should be any query. Okay.
yes, sir.
Okay, so we'll take one more example now. Okay, so this will be a simple example. So let us take the value of I want to know what is the value of I, that is integration from, let us say, 1 to, let us say, 3 of x square dx. Okay, इसका इंटीग्रेशन क्या आएगा, कोई बताएगा मुझे? एक्चुअल इंटीग्रेशन क्या आएगा?
X cube by 3.
This is x cube by 3 with limit 1 to 3. तो यहाँ पर मैं क्या लिखूँ अभी?
3 cube by 3 minus 1 cube by 3.
By 3. So this becomes 9 minus 1 divided by 3. So this becomes 8 by 3. How much is this 8 by 3?
8.6667.
No, 8 by 3.
2.6666.
2.66667. So this is the actual answer, isn't it? So now let us try to find out what will be the solution.
सर वो 3 का क्यूब 27 होगा.
Sorry.
सर 3 का क्यूब.
Oh, sorry, my mistake. This will be 27. Okay, 27, और यहाँ पे आएगा अपना 26. This is 26 by 3. How much is this now?
8.666.
8.66667. Okay, good. So now try to find out the integration of this using, let us say, 8 intervals only. Okay, straight away you take 8 intervals. So now you will have a values probably like this. Okay, so you will have the x and y values. Okay, um, so you will have say 1 2 3, right? So this will be 1, and this will be 3. So in between you will be having 2, and here you will be having, say, 1.5, and here you will be having 2.5, and this will be 2.75, and this will be 2.25. बराबर है ये? This will be 1.25, and this will be 1.75. Okay, so corresponding y value now you will have to calculate. Please do the calculations. Give me the values, please. Everybody, please do your calculations, because in the examinations you have to solve the problems. And why I'm taking so many problems, because you should have a practice. Okay, so please do your calculations by your own. It will also help you in understanding the subjects. Okay.
Sir, is there any formula for calculating the number of intervals?
Sorry.
Is there any formula to calculate the intervals?
No, no, this is taken randomly. Okay, in examination number of intervals will be given to you. Why I have taken so many intervals, because I just wanted to explain you how this number of interval is affecting the accuracy of the solution. Okay, so more number of intervals, more solution, but more accurate solution, but it will always uh, involve more number of calculations. Okay, so in order to get accuracy you have to put more efforts in calculating. Fortunately we have computers, so computers it becomes very easy, है ना? चलो अभी तुम लोग कैलकुलेट करो. So here it is quite simple, I suppose, because y is nothing but function of x, and here the function of x is only x square. So all we have to do is just write down the square values which are over here. है क्या बेटा? Anybody?
8.6875.
Hmm, I think this is 1. Okay, then we have 1.56. Okay, and this is 2.25, and this is 3.06. बराबर है ना बेटा ये? Okay, this is 4, and this is 5.06, and this is 6.25, and this is 7.56, and lastly this is 9. Okay, so these are the y values. Okay, so y values is nothing but f of x, and your integration, that is I, now it will be something like h by 2 into this will be your y1. So this is nothing but your ya, sorry, not y1, this is ya, and this value will be your yb, and this will be y1, y2, y3, y4, y5, y6, and y7. So this is 2 times, this will be y1 plus y2 plus so on up to y7 plus yb. Okay, what will be the value of h over here? H is nothing but the distance between two consecutive values. Okay, so your h will be 0.25. Okay, so this is 1 plus 2 times all these terms plus this is 9. कितना आ रहा है बेटा आए?
8.437.
437. 7 के बाद क्या है? 9.
8.4375.
75. Okay, so you see the actual answer, and you see the answer which we have got after taking the 10 intervals. Okay, so still you can see there is a significant amount of improvement which is required even after taking 8 number of intervals.
Sir, my answer is 8. Yes,
कि,
687.
कितना आ रहा है?
8.8.
कितना? 8.687.
687.
Okay, ठीक है. So now still 0 point sorry 8.6, 8.6 तो common है, only the second digit onwards improvement is needed. Okay. Okay, so it is advised don't do some calculation mistakes because it is going to cost you marks. Okay, so please ensure that you are doing correct calculations. Okay, I hope this method is clear to everybody.
Yes, sir.
ठीक है, then we will stop now. Okay, next class we will be covering the remaining portion. Okay, I have